Welcome back. In a previous video we drew this schematic in EasyEDA, and today we are gonna generate a PCB, or actually we're gonna design a PCB, and then we can have that manufactured if we want. First things first, let's make some more sense of these labels, because now it's just R1, R2, R3, R4, etc., which doesn't really help when you're looking at the schematic or the PCB. So let's label them in a way we can more easier understand where they belong. So this is R1L, which means R1 left because it's part of the left channel, and then we call this R1 right. And I'm going to do that for all the components. Just going to fast forward this because it can be a bit tedious to watch me rename all the labels. In the background you may hear some buzzing. That's my 3D printer printing out a case for a project I'm working on. And should I give it away? Well, maybe I can just give it a little hint. I'm using something that Sion, the unexpected maker, designed. I'm not going to tell you what it is. There's a video coming up real soon, so stay tuned. Now that I've labeled everything in a way I can understand it, and hopefully other people can as well, it's time to convert this to a PCB, which is up here between the star and the tools, and I think this is supposed to be a PCB, and then go to convert to PCB. But before you do that, if you don't save your design before you convert it to a PCB, EasyEDA will start to complain and tell you to save it. And because I don't like to be told what to do, I just do it myself. Go up there, click save, and then it says saved successfully, and then I go up here and convert to PCB. And that gives us our default PCB view. Now what I'm going to do is talk a little bit about how I do it, how my process works, and fast forward the bits where I'm doing all the traces, just rearranging, making small adjustments. And when I run into a problem or something I think is handy for you to know, I'll just slow it down again and talk a little bit about that. In my case, I came up with a design of the PCB on a whiteboard, rearranging components and coming up with a design I liked. So I'm going to use that as a guideline for drawing the PCB in EasyEDA. And the first thing I'm going to do is delete the board outline. This is this purple layer over here at layers, and the purple line is the edge of your board. Just going to delete that. And looking at my whiteboard design, I'm going to place those components that are the biggest first and place them in roughly the place I want them to be. Again, R rotates the component. Make sure you select the whole component, not just the label, and place them in roughly the right spot. I'm going to start with the power circuitry first. So just grab all the components that belong to the power circuit or the power supply and just place them near where I want them to be. I also need R5 left and R5 right. Just move them up there. And I need the R LED. Because this is going to be a very lengthy video, if I do this all in real time, I'm going to fast forward a few bits. But the thing that is important is the trace width, which means the tracks between the components. And this is dependent on the current that will be flowing through it. You can calculate that using a formula, but there is a website I found, and it's called 4pcb.com, which gives you the required trace width if you put in the current that is going to be flowing through. I know my circuit is never going to draw more than 400 milliamps. I measured that actually, so I'm going to put in 0.4 amps, which gives me a required trace width of 8.69 millimeters, and I'm going to round that up and make it 10 mils. Did I say millimeters? I meant mils. This is an important thing to know. There's mils and millimeters. A mil is 1/1000 of an inch, and a millimeter is, well, a millimeter. You can set the default units on your canvas, on your board design. If you click on the canvas, go up to the right, top right, and there you can select mils, inches or millimeters. I'm going to set it to mils, and my default routing width is 10 mils. So every trace I make, which is up here on the PCB tools, it's called track, is going to be 10 millimeters, 10 mils wide. What I haven't told you that, I guess, the same as with the schematic, the middle mouse button, scrolling it zooms in and out, but holding down the middle mouse button will allow you to move your canvas around. What I'm going to do now is place all the components and route them, and in the meantime I'm going to fast forward this and put on some music just to make it a little less boring. Now, what I'm actually going to try and do is keep the through-hole components on the bottom layer of the board, because that will give me a bit more routing and tracking room on the top of the board where all the surface mount components are, which of course I can't route on another layer. So if you go up here to layers and select the bottom layer, your trace will become blue. And that means it's on the bottom side of the board. Now I can't get from this pad to this pin on the output, so I'm forced to go on the other side of the board, and I do that by placing a via, which is like a tunnel to the other side of the board, of course, and that way I can route this pad to that pin. So now I've routed all the traces. The rest is just aesthetics. You can move parts around and make it look a bit nicer, but most things are done now. I'm just going to move these labels over there. As you can see, there are some unrouted traces. These are all ground. I'm not going to route them. I'm going to create a ground plane. But first I have to set the board outline. So I go up there to layers, click on board line, and then click on trace, which in this case isn't a trace, but is just the board outline. And I'm going to start at the lower left corner, go all the way over to the left. Make sure they're 90-degree angles. Go up there. And you can see the crosshairs will tell you where you are in relation to the, in this case, the bottom part of the PCB. And go down and then right click to finish, and that's your board. The ground plane I create using this one, and it says copper area. I'm going to do that on the top layer of the board, and this is not really important as long as it covers the whole board. So you can do it outside of the board. Just go 4 corners, 1, 2, 3, and then again when you're done, click left, click right, and it will fill in the board with copper area, and that's your ground plane. Basically we're done now. I'm gonna put in some mounting holes just because that's easy. Put one there. I'm going to put one there. I'm going to put one there, and I can put one. Can I do it like this? I'll put one there. I'll just move this over a bit. There we go. Now you can do some text as well. Just put your name on it, or the name of the device, or anything. I do that on the top silk layer. And you can click that to edit it, click the text logo and place your text somewhere, and then click it and go up here to the right, and there you can put in your text. Just call it MiniAMP version 3. There we go. And that's it. We're done. Basically, you can now export it to a Gerber file and have it manufactured by your favorite PCB manufacturer. Or you can just export it from here directly to JLC PCB. There are enough tutorials on that on YouTube, so check them out. If you like this video, thumbs up. Don't forget to hit subscribe, and if you have any comments or questions, leave them in the comment section below. Thanks for watching.